Yes, sir.
Okay, so we can start now. I suppose we can start now.
Yes, sir.
Okay. So when we talk about case number 3, case number 3 is a combination of case number 1 and case number 2. So alright, when denominator has few repeated and few non-repeated linear factors. And actually this article is having the potential to be asked for 4 marks because it tests two different basic concepts. Okay, so we shall have practice on this article much more. Okay, and as I said that practice questions I will be discussing after I explain all 4 examples of case 1, 2, 3 and 4. Okay, so this is the case third. And solving the question based on this case number 3 is very easy. Suppose we generate x square plus 3x minus 1 divided by x plus 3 whole square into x minus 1 into x plus 3, or sorry, x minus 3, or let us take x minus 2, entirely 3 different numerical values. Okay, so question says, as per this article, we could see the repetition of a linear factor and simultaneously we are having non-repeated linear factors also. So splitting such rational expression in the form of its partial fraction is very easy. What we will do, we will apply the concept of non-repeated linear factors for this too, and we shall apply the concept of repeated linear factor for this factor x plus b whole square. Okay, so splitting this, we shall be having x square plus 3x minus 1 divided by x plus 3 whole square into the bracket x minus 1 into the bracket x minus 2. This will be equal to, you know, for non-repeated linear factor, one constant for the denominator x minus 1, for the factor x minus 1 I mean, another factor or another constant for the factor x minus 2. And now we know that for repeated linear factor, for this type of linear factor, okay, we are required to start taking the denominator from x plus 3 whole to the power 1. So we write one constant like c divided by x plus 3 and one more constant we take d divided by x plus 3 whole square. And now I am not left with any shortcut method. So my worries would be, how could I save time? Okay, for time saving devices, whatever devices I was having, I already have used for article number 1 and for article number 2. But for this method, I don't have any specific method which could save our time, but I will be using that improvised method of finding out the values of A, B and C. Correct? And if I am left with no other alternative, then only I shall have that method of equating the coefficients of like terms on both the sides and generating as many equations as there are number of constants involved in the partial fractions. Correct? So that would be a time consuming procedure.
You got muted. Sir,
plus c into the bracket x minus 1 into x minus 2 into x plus 3 plus d into the bracket x minus 1 into x minus 2. Okay. Other complete board is visible?
Yes, sir.
Okay. So when I take LCM, I cancel out denominators of both the sides. Okay. And you please allow me, you write this particular question elsewhere so that I clean the board and I will be able to write down it in that area where you will be able to see it properly and clearly. Okay. So I get the quantity like x square plus 3x minus 1 is equal to a into the bracket x minus 2 into x plus 3 whole square plus b into the bracket x minus 1 into x plus 3 whole square plus c into the bracket x minus 1 into x minus 2 into x plus 3 plus d into the bracket x minus 1 into x minus 2. And we have yesterday discussed that x is going to be an arbitrary constant. So now we shall try to put the value of x which can be derived with the help of the factors which are involved. So you could see that the original question was having three different linear factors in the denominator: x minus 1, x minus 2 and x plus 3. These three different linear factors had in there in the denominator, and we are having four constant quantities to be evaluated. Okay. So now you see that number of constants are more and number of factors which are in the denominator, different linear factors I am talking about. Different linear factors in the denominator, they are less, and number of constant quantities involved, they are more. Okay. So in this particular situation, what are we supposed to do? That I am telling. Say three different factors equating one factor to 0 and getting the corresponding value of x. Okay, suppose if I equate x minus 2 to 0 and I write x equal to 2. So now you see what is going to happen. If you put x is equal to 2, then wherever is the factor x minus 2 present, all those factors will be vanished. All those quantities will be vanished. Okay, because putting x is equal to 2 will make the expression x minus 2 equal to 0. And you could see that putting x equal to 2, term containing a, term containing c, term containing d, these three terms will vanish and we are left with the quantity containing constant b. Is it okay? So calculating the value of b will be very easy. Okay, that is the first thing. Likewise, if I put x is equal to minus 3, if I put x is equal to minus 3, then I will be able to get the term containing d. Except the term containing d, remaining terms all have got the factor x plus 3. So their numerical value will become 0 and I shall be able to calculate the value of d. So now you see that when I write x is equal to 2, okay, I will be able to get the value of b. When I write x is equal to minus 3, this will give me the value of d. And now suppose if I put x is equal to 1, because the third factor was x is equal to 1. So when I put the value of x is equal to 1, the term containing b, the term containing c and the term containing d, these three terms will vanish because of the presence of factor x minus 1, and I will be having the value of quantity a. Correct? But now apart from these three values, apart from this value, still I don't have the value of c. I could not calculate the value of c directly from this situation. So under that condition, what to do? So I will suggest that you put such a value of x, which gives you some sort of convenience for calculation. Okay, means pick up that numerical value of x other than x is equal to 2, minus 3 and 1, other than 2, minus 3 and 1, because these values already you have selected and these values have already given the values of three constants. So you pick up one value of x. I prefer that value equal to x because calculation with the quantity 0, x equal to 0 will be preferred value because calculation with the numerical value 0 will be easier for me. Okay, so now what is going to happen? You try to understand that putting x is equal to 0. Could you see any factor of the four terms over here is getting equal to 0?
No, sir.
No. So as a result, now what will happen on the right hand side? You will be getting the expression containing a, b, c, and d. Means of course some coefficients will be there for each and everything. Okay, I'm not calculating the coefficients of A, B, C, and D. Right now, what I wanted to show you is that okay, the RHS will be in the form of A, B, C, and D, and LHS will be in the form of a constant. Putting x is equal
-1.
to 0, you are going to get -1. Okay, so now how to calculate the value of C? So you see that putting x equal to 2, -3, and 1 respectively, we have got the values of B, D, and A. That means out of these four terms, the value of A, B, and D, it already has been calculated by us over here. Correct? So this fourth value you should select other than these three factors. Okay, and putting this value, you will be getting an expression containing all constant quantities. And after getting all constant quantities, out of them, maximum have been calculated over here. Okay, so you will be able to get the value of the fourth one. Okay, say difficulty level of the question can be pre-imagined before you start solving the question. How can you do that? Okay, look at this partial fractions once again. How many partial fractions are there? 4. Okay, and how many different factors are there? 3. So could you see there is a deficit of 1 unit in the number of constants and in the number of different linear factors? Okay, so as a result, now what is going to happen? You are required to get this type of expression, means this one value, it other than the factors, other than the value of x which can be obtained with the help of the linear factors, you are required to go for one value. Okay, and since this particular expression is right now being discussed, let me divert your mind for a fraction of minute. Suppose if I write x upon x plus 1 whole square into x plus 2 whole square. Suppose if I am writing this type of factor, in that case what is going to happen? How many partial fractions will be present for this expression?
4.
4. Okay, what will be those? A upon x plus 1 plus b upon x plus 1 whole square plus c upon x plus 2 plus b upon x plus 2 whole square. And how many different factors are given in the question? 2 different factors are given. And how many constants are there? 4 constants are there. Okay, now you compare this scenario with the original question what we had been discussing. We were given 3 different factors, so 3 numerical values of x could be calculated, and there was a deficit of only 1 between the number of constants and the number of factors. But over here, the deficit in the number of constant and in the number of factors is 2. So we will have to select 2 values of variable x in this manner, so that we shall be getting 2 equations containing all 4 constants. Okay, 2 equations containing all 4 constants. But out of those two equations, we might have calculated the value of two constants out of 4. Okay, so now this type of question will be little bit lengthy. Again, lengthy, it is time consuming. So why I am asking you to compare the situation, so that before you start solving the question, you should be having an algorithm in your mind which suggests that how much time you are likely to take for getting the answer of the problem. It's not that without estimating the time you are solving the question, and thereafter, suppose in my opinion a 3-mark question should be solved maximum within 7 minutes. But if some child takes more than 7 minutes, it means it will be on the cost of writing the answer for some other question. Means if you are taking more time, it means that you are not able to write down the solution of some other question in the examination. Okay, so you are required to practice up to such an extent that all 3 marks questions are compulsorily, without loss of accuracy, are being solved by a student within 7 minutes time. This is my anticipation. Okay, again, so Atharva, you please copy this question, because immediately after solving the first question, I will be providing you the solution of this question. Okay, so you please copy this steps, and you remind me little late. So let us calculate the values of all constants as per the question. If I put x is equal to 2, So putting x is equal to 2. Okay, I will be getting the term containing b. So putting x is equal to 2, the LHS will become, what is the value of LHS? 4 minus 1, 3 plus 6, 9. So 9 is equal to b into the value of this one, 2 minus 1, 1, 25. So 25b. 25 into b is equal to 9. That gives you b is equal to 9 by 25. Okay. Putting x is equal to minus 3. So putting x is equal to minus 3. So 9 minus 9 will be 0. 0 minus 1 is equal to minus 1. And putting x is equal to minus 3 as I said. So minus 4 into minus 5 will make it plus 20. So that will be giving you d into 20. So this will imply d is equal to minus 1 upon 20. And putting x is equal to 1 will give you the value of a. Putting x is equal to 1 gives you the value of a. Okay, so this will be giving you 3. 3 is equal to minus 1, 16. Okay, minus 16. 3 is equal to minus 16 a. So that will imply a is equal to minus 3 upon 16. Okay. And now, after calculating these three values, we are selecting this fourth value, which is most suitable value for calculating the values of x. Okay. Oh, sorry. Calculating the value of the fourth constant. So, Atharva, I understand. Miss, I hope you have understood this procedure. How are we selecting this fourth
Yes,
value
sir.
of x? Okay. So, putting x is equal to 0, we get left hand side minus 1 is equal to. Okay, this becomes minus 2 into 9. So minus 18a, minus 18a, minus 1 into 9 will make it minus 9b. And 2 into 3, 6c. So that gives you plus 6c. And here minus 1 into minus 2 will make it plus 2. Okay. So we are going to get the equation minus 18a minus 9b plus 6c plus 2d is equal to minus 1. And B, D, and A, these three numerical values we are having. So we shall be in the position to calculate the value of means leftover constant C. Okay. So it is time consuming, but we are doing that thing. Okay. So minus 1 is equal to minus 18 into the value of A is minus 3 upon 30 upon 16. Okay. So this is one quantity. Minus 9 into the value of B is 9 upon 25. So this is 9 upon 25. Okay. And finally, minus 9 plus 6c plus 2 times the value of D. D is equal to minus 1 upon 20. Okay. So we are required to take LCM. Okay. And taking LCM, what will be the LCM? 100? No, cannot be 100. We calculate 16, 20, 25. Okay, so I write 4, 4, 5, 25. Okay, so that will be the LCM. Even 5, if I write 4, 1, 5. Okay, 400 will be the LCM over here. Okay, 400 will be the LCM. So we write 400 here in the denominator. 25 into 54. So 25 into 54. Okay. That will give you 12,600. Oh, somewhere I am committing mistake.
Sir,
It's 135. Okay. 1350. So this is 1350 minus 81 into 16. Minus 1296 plus 2400C, and that will be equal to minus 40. Okay, so this is the way in which you will be able to calculate the value of C. I hope I should not go in further details.
Sir,
Yes.
sir, like A and B and C, they are becoming cubic. So somewhat of x cube into A plus B plus C, and x cube's coefficient over there is 0. So they can also be equated, na?
Okay, you are wanting to equate the coefficients over here.
No, sir, in the topmost part, like where we compared the equation. Yes, sir. So
Yes.
A, B, and C are becoming somewhat coefficients of a cubic, because there the highest power will go 3.
Yes.
So they can also be equated to 0, and C will be easier to find.
No, I tell you one thing. It's not that only A is equal to 0 or B is equal to 0. The sum of the three coefficients is going to be equal to 0. Means
Yes,
you will
sir.
be
Yes,
having
sir. That's only I am saying.
summation of three numbers equal to 0 doesn't mean that each one of those three numbers is equal to 0. Okay. Yesterday we did that thing only for x square because there was single term containing x square. Okay. So here sum of the three variables is coming equal to 0. It doesn't mean that all three are equal to 0. Okay. So mind it.
Nice. So from there, C will be equal to minus of A plus B.
What? Okay. Suppose if you are able to get that thing, then in that case values of A and B we are already having here. Okay. Means now you see that. Say this will be a time consuming procedure. Now whatever procedure you adopt, according to that you are required to spend the time. Okay, so I spend this much time for calculation of C. You can spend okay, either time spent by you for calculating the value of C would be little less or would be little more. Correct? So you should be able to compare this type of things after performing certain experiments. Okay. So the student, when he is writing the examination in the final examination, he is writing the answers, he should know which method will be most improvised method in terms of saving the time. Okay. So my intention is just to show you what way we can improvise our method that reduces the time for solving the question. This is my intention. Okay. So in this also, whatever efforts I am putting, I am not experimenting actually. So when we go for some sort of experiment, we try to compare different results, and result will be not in terms of the values of A, B, and C or values of all constants. Result will be in terms of the time taken by you to get the answer. Okay. So our intention should be to find out the values of all constants accurately, but time taken by us in that process should be minimum. This is our effort. Okay. So I hope, students, you will be able to calculate the value of C. Do you want me
Yes,
to
sir.
calculate the exact value? Minus 400 minus 414 divided by 2400. Okay, this is the value of C what I am getting without simplification. Minus 414 divided by 2400. Okay, this is the value of C I am getting. And now when we talk about getting the numerical value, now you see, you can see that value of A, B, C, and D, all values are calculated. So here partial fraction will be in the form of minus 3 by 16 upon x minus 1. B has got the value of 9 by 25. So you write plus 9 by 25 divided by x minus 2. The value of C, if calculated by me, is right. I should write minus of 414 divided by 2400 divided by x plus 3. And if we write the value of D, it gives you minus of 1 upon 20 divided by x plus 3 whole square. Okay. So when this type of question is asked for integration, means suppose if this is the situation that we are asked to integrate this particular question, then how should we go for integration? Because as I said yesterday also and today also, I am reminding that the method of breaking into partial fraction, it will be utilized for integration purpose. So you see that integration of the whole fraction or integration of the whole rational expression is equal to integration of respective partial fractions. So keeping that thing in mind, suppose if this type of question is given, so it could be integrated over here by integrating the first partial fraction plus integration of the second partial fraction, integration of third partial fraction, and integration of the fourth partial fraction, like that. Okay, so here directly one can write the answer minus 3 by 16 into log of x minus 1 plus 9 by 25 log of x minus 2 minus 414 upon 2400 into log of x plus 3 minus 1 by 20, it is outside, and here when we write x plus 3 whole square, so it will be giving you minus of 1 upon x plus 3. Okay, so this minus multiplied by minus will make it plus. Okay, and plus plus constant of integration that we can write. Okay, so this way we are able to break the given algebraic expression or rational expression in the form of its partial fraction, not only breaking into partial fraction, but we will be able to integrate this type of functions which are not in the standard form. That was the basic purpose of using the integration of partial fraction, integration by partial fraction. That the standard forms, if they are not available with us, then we can break it in the form of some portion which are broken in the form of standard functions, like that. Okay, and here let me generalize one small thing for you, Atharva. Here you see that whenever we got only linear factor in the denominator, fortunately it so had happened that everywhere coefficient of x is 1. Okay, so I wanted you to generalize. Okay, so I'm just deviating you from this particular question to some other question. Suppose if I get the integration of ax plus b dx upon ax plus b, like this, so what will be the answer? Here I have taken coefficient of x other than 1. Okay, so please see the procedure so that in later on situation also, later situation, we shall be able to write down the answer orally. Okay, so here if I write 1 upon ax plus b into dx and I go for substitution, so I write ax plus b is equal to t. So when I differentiate, what is the derivative of what is the derivative of ax? It is a plus derivative of b 0 is equal to dt upon dx. Okay, so here we get a into dx is equal to dt, and the value of dx will be equal to dt upon a. The value of dx is equal to dt upon a, and if we do this thing, we are going to get 1 upon t into the value of dx becomes dt upon a. A being a constant in the denominator, you can write it outside the integration, so it will give you 1 by a integration of 1 upon t dt. And you know what is the integration of 1 upon t dt? That you know. Okay,
Yes.
so what is the final answer? 1 by a into log of
ax plus b.
Okay, so I wanted to highlight the constant quantity a present in the denominator. Okay, so now you look at the situation. Suppose we are having any linear expression in the denominator, so integration of that will be always in the form of log of ax plus b. That means the same linear expression within the log function will be the answer. But along with this answer, you are required to multiply it by 1 by a, that is coefficient of x. Correct? So suppose if we are having this expression here, suppose minus 3 by 16 into minus 3 by 16 upon 3x minus 1. Suppose if this is the question, so orally what would have been the answer for this integral?
One upon 3 log x minus 1.
Yes, 1 upon 3 into log of x minus 1. Okay, now see that I am changing this to 1 minus 3x here. So
Minus 1 upon 3 log of 1 minus 3x.
yes, okay. So keep that thing in mind. Always keep that thing in mind. Okay. So since we were dealing with this linear expression and their integrations, so I thought I must share this thing also with you. Okay. So I hope case three cases we have discussed. Okay. So now you tell me one thing. Do you want to go for practice for this type of questions, or you wanted to learn the fourth case?
Sir, fourth case and then practice of all together.
Okay. Case 4 says when denominator has such a quadratic factor that cannot be factorized into real linear factors. So this is the most important thing, that the quadratic factor present in the denominator should not be expressed as a product of real factors. So first thing what you are required to do, the moment you see the quadratic factor, you are required to check the determinant. If the determinant comes out a negative number, then always you can say that such a quadratic cannot be factorized into real linear factors. And in that case, what we are required to do, see this. Suppose if I write 1 upon x cube minus 1. Suppose if I write this particular question. Okay. So now this is a cubic expression in the denominator, but fortunately could be factorized to write down. It is a cube minus b cube. So a cube minus b cube formula can be applied over here, and we can go for factorization of the expression like x minus 1 into x square plus x plus 1. Okay. Now this case what I have written, I would be highlighting the quadratic part, no doubt. But apart from that quadratic part, this linear part h minus 1, this is non-repeated linear factor. Okay. So rules for non-repeated linear factor should be applied here also. So we write a upon h minus 1. And for this quadratic factor, h square plus x plus 1. Okay. So now what should we write? This is a quadratic. So in the numerator, we should try to write down a linear expression. This is the fact which we have to keep in mind. Okay. Say here, degree of denominator over here was 1. So we wrote in the numerator one expression whose degree was 1 less than that of denominator. Okay. So here degree of denominator is 2. So we should write in the numerator one such expression whose degree is 1 less than that of denominator, means 1 less than quadratic, and 1 less than quadratic, that means a linear one. So please pay attention. For having such a quadratic factor which cannot be factorized into real linear factor, what should we write in the numerator? We should write a linear expression in the numerator for all such quadratic in the denominator. Okay. I hope you have understood this one.
Yes, sir.
Okay. Now you see how much time you will be able to consume for calculating the values of A, B, and C. How many different factors are available which give you the value of x? And how many constants are to be calculated?
3.
3 constants. And how many factors do you have for calculating the values of x directly?
Yes, 1.
1. Because this will not be giving you the real values of x because of this condition. Okay. So there will be no real value of x which you can obtain with the help of equating this factor to 0. Okay. So there is only one value of x what you can directly get from this factor, and there are 3 constants. So how many, what is the deficit over here in the number of constants and in the number of values of x? 2.
There are 2, yes, sir.
Means you will have to select 2 arbitrary values of x other than x is equal to 1. Please see the procedure now. Okay. So suppose now if I take LCM over here, after taking LCM, what is the numerator on the left hand side? 1. So I am writing that 1 over here. Taking LCM, I will be getting a into the bracket x square plus x plus 1 plus x minus 1 into the bracket bx plus c. And of course, denominator of RHS and denominator of LHS will get cancelled. Okay. So this equation we are having now, and our target would be to find out the solution of three constants A, B, and C. Okay. Original question, let it be here only. Okay. So here now, putting x is equal to 1. Put x is equal to 1. So putting x is equal to 1 will have no impact on LHS. It remains 1 only. 1 is equal to. Putting x is equal to 1 will make this entire term equal to 0. Product of 0 with bx plus c. The entire term will vanish. Okay. What is left over? The term containing a. Okay. In this you put a is equal, x is equal to 1. So 1 plus 1 plus 1. You are going to get the value of a is equal to 1 by 3. Is it okay?
Yes, sir.
So, okay. After taking this numerical value, now we are not left with any value of x that could be calculated with the help of the present factors. So we take two arbitrary values, and taking two arbitrary values, you take those values which are very easy for performing the mental calculations. So one of them would be x equal to 0, and the other one which I am writing will be x is equal to minus 1. Okay. So these two values, they are not derived directly from equating the factors available to 0, but we are taking these values from our own side. Okay. So putting x is equal to 0 will make the left hand side 1 is equal to a, and putting x is equal to 0 over here, this is minus 1 and this is c, so that is minus c. Okay, so 1 is equal to a minus c. This is the equation what I am getting. The value of a already is calculated 1 by 3. So this will imply c is equal to 2 by 3, minus 2 by 3. 1 minus 1 by 3, 2 by 3. So c is equal to minus 2 by 3. Okay. Main thing was putting x equal to 0. We got original equation that contains more than one constant quantity here. Okay. Likewise, putting x is equal to minus 1. Putting x is equal to minus 1, LHS is equal to 1. Minus 1 plus 1 will be 0. So your first term will be equal to a. Minus 1 into minus 1 will make it minus 2. Minus 2 into minus b. So that will be making plus 2b. And minus 2 into c will make it minus 2c. Okay. So this is an equation containing all constant quantities a, b, and c. But by now we already have got the values of a and c. So this will help us to calculate the value of b. Okay. So value of a is equal to 1 by 3 and 5 by 3. 1 minus 5 by 3, that means minus 2 by 3. Minus 2 by 3 is equal to 2b. So that will imply b is equal to minus 1 by 3. Okay. So I got the values of a, b, and c in this specific format. Okay, a is equal to 1 by 3, b is equal to minus 1 by 3, and c is equal to minus 2 by 3. Okay, so therefore we can now break this expression 1 upon x cube minus 1 in the form of 1 by 3 divided by x minus 1 plus bx plus c. It was bx plus c. That means minus 1 by 3x minus 2 by 3 divided by x square plus x plus 1. Okay, so here you can write this in the form of 1 by 3 into 1 upon x minus 1, like that. Take minus 1 by 3 common. So taking minus 1 by 3 common, you are having the quantity like x plus 2 divided by x square plus x plus 1, like that. And now suppose if we are given the integration of this original function, so integration of 1 upon x cube minus 1, it would have given you the integration of 1 by 3 times 1 upon x minus 1 dx minus 1 by 3 outside integration of x plus 2 divided by x square plus x plus 1 dx. Okay, and now you see that gradually dealing with this specific format or dealing with this specific case, the integration of a function, what we are getting, this function is getting little bit complicated because solution of this one will be based on integration of linear upon quadratic. Okay, am I right? So now you see that whenever we are dealing with this case number 4, whenever we are dealing with the case number 4, okay, the solution of the question will be little bit lengthier in comparison to first 3 cases. So I hope Adhar you will be able to get the answer of the problem now.
Yes, sir.
Even this x plus 2 divided by x square plus x plus 1, this also can be solved by you. There is no problem.
Yes, sir. Yes, sir.
Okay, so that was explanation from my side for 4 different cases which are there in our syllabus right now. There exists one more case, that is repetition of this quadratic factor that cannot be expressed in the real linear factor. Okay, with this type of case also is available in integration, but right now it's beyond our syllabus, so there is no question of touching that right now. Okay, so explanation of this 4 cases is over. Now we are left with the practice question. Okay, so should I write?
You are not audible.
So when we try to factorize this, we get it in the form of x square whole square minus 1 square dx, and we can write that in the form of 1 upon x square plus 1 into x square minus 1 dx, and this will be simply written in the form of x square plus 1 into factorization of x square minus 1 can be written in the form of x minus 1 into x plus 1. Okay, so now you see that this is the expression containing one quadratic x square plus 1. When you try to factorize this quadratic, it cannot be factorized into real linear parts. Okay, and x minus 1 and x plus 1 can be divided into real linear factors. They are already the factors. So we can write it in the form of a upon x minus 1 plus b upon x plus 1 plus, when I write this quadratic factor in the denominator, what should I write in the numerator?
Cx plus d.
Yes, so you please write cx plus d. And now you estimate how difficult is the question. How many constants to be evaluated?
4.
How many factors are there which will give you direct values of constants?
2.
2. So, okay, so 2 times you will have to take the arbitrary value of x, and thereby you will be required some additional time for solving the question. So please try to find out solution of this question. I am also over here with the solution of the question hereafter. Okay, so you please try to get the answer of the question now.
Sir, C is coming out to be 0, D minus 1 by 2, A minus 1 by 4, and B 1 by 4.
I was getting value of A is equal to plus 1 by 4.
My
I
B
got,
is plus 1 by 4.
okay. Tell me, where have you written A? Along with x minus 1 or along with x plus 1?
I written with x plus 1.
Okay, perfectly all right. Perfectly all right. Constant with x plus 1 is having the value minus 1 by 4. Constant with the factor x minus 1 is equal to 1 upon 4. Okay. Means you see, if you could see the board, on board I have written A and B in this manner, but denominators means your answer and my answer, they are different. Different only in one sense, the numerical values of the constant, but when final answer will be taken, both of them are correct.
Yes,
You
sir.
just you just 1 minute time for me to calculate the value of C also, because the values of A, B and D I already calculated. A, B and D I have calculated over here. I was just on the verge of calculating the value of C.
Yes,
Okay.
sir.
So I get 1 is equal to 15 by 4 and minus 5 by 4 plus 6C and minus 3 by 2. Okay. So 10 by 4 minus 6 by 4 means minus 1, 2. So C is equal to 1 by 3, no? What is
I
value of
got it.
C? Of C is
I
equal to
got
1 upon
0.
3? No,
I,
0 cannot be. Yes, C equal to 0. Yes, C equal to 0. Perfectly all right. C equal to 0. Okay. So putting C is equal to 0 means final answer would be like minus. Final answer what we are having, it will be equal to 1 by 4 divided by x minus 1 minus 1 by 4 divided by x plus 1, and value of b what we are getting is minus 1 upon 2. So minus 1 upon 2 divided by x square plus 1. Okay. So when we integrate this one, when we integrate 1 upon x to the power 4 minus 1 dx, what answer are we going to get? 1 by 4 log of x minus 1 minus 1 by 4 times log of x plus 1 minus 1 by 2 times tan inverse x plus a constant. Okay. So this is the way in which we are going to get the answer of the problem.
Yes, sir.
Yes. So I hope there is no problem for you to understand in these 4 cases. And one question of the practice we have solved over here also. I am writing one solution of one more question for you. Means now level of difficulty can be slightly increased by applying this concept to trigonometric functions. Applying this concept to trigonometric functions. Okay. See one question if I write sin x divided by sin 4x. Suppose if I write this question, or else if I write cos x divided by 1 minus sin x into 2 sin x plus 1 into 3 plus sin x dx. Suppose if I write this type of trigonometric function, this one. First question what I have written, I am going to provide you the solution. And this question which I am writing over here, this is very, very easy question. Okay. You just
Yes, sir.
see
Sin
that.
x can be assumed as anything.
Yes, sin x is equal to anything, and you can convert this in the algebraic expression. Miss,
Yes, sir.
normal
Yes.
fundamental is that. Normal fundamental is that if we are given a trigonometric function, we go with a algebraic substitution, and we can convert this trigonometric into algebraic one. Wherever some algebraic expression is given, we can go for converting it to trigonometric one, and we can evaluate. Both of the situations are there. Okay. So I think when you substitute sin x is equal to t, the question reduces to dt upon 1 minus t into 2t plus 1 into 3 plus t. So all non-repeated linear factors, okay, you will be able to get the answer of the question. Okay. Now see this one. The first question what I have written. This is sin x divided by. When I try to split sin 4x, I will be able to write it in the form of 2 times sin 2x into cos 2x. Correct? This is equal to sin x dx. When I again try to divide this in the form of 2 into 2 sin x cos x. Okay. Into, when I try to write down cos x, cos 2x, I can write that in the form of 2 sin square x minus 1. Is it okay? So 1 sin x got cancelled with 1 sin x. Okay. So this is equal to integration of 1 upon 4 outside, integration of dx divided by, first term left over is cos x into 2 sin square x minus 1. Okay, and here I will write it in the form of multiplication of cos x and division by cos x, and this 2 sin square x, 2 sin square x can be written in the form of root 2 sin x minus 1 into root 2 sin x plus 1. Okay, so factorization of this expression 2 sin square x minus 1 can be done in this format. Okay, so root 2 into sin x plus 1 into root 2 into sin x minus 1. And here dx. Now, I hope this cos square x what I am writing, you can write that in the form of 1 minus sin square x. And even factorization of 1 minus sin square x in the form of 1 plus sin x into 1 minus sin x can be done. So this becomes 1 by 4 times cos x dx divided by 1 minus sin x into 1 plus sin x into root 2 sin x plus 1 into root 2 sin x minus 1. And again, following the substitution, sin x is equal to y. So this will imply cos x dx is equal to dy. And the original function will become now 1 by 4 times integration of dy divided by 1 minus y into 1 plus y into root 2y plus 1 into root 2y minus 1. Okay. So I hope hereafter you can find out the solution of this question. Is it okay, Atharva?
Yes, sir.
I hope you will be able to evaluate the constants related to all these quantities, because shortcut method also can be applied for the same to get the answer.
Yes, sir.
Okay. So here I have not taken any book into consideration so far. So far as practice questions are concerned, whatever questions those came to my mind, I have directly written those questions on the board and I have started providing you the solution. Okay. One more question. I think this question is again given in the NCERT book also. That question also I'm going to write for you.
Sir, please let me note this one. This one is an interesting question.
Okay. Please write. I am writing that question again. Sin x upon sin 4x, please.
No, sir. No, sir. I will write that.
No, it's okay. I'm not going to clean. Okay, you take your own time. Take your own time, please.
Yes, sir. Now I wrote it.
Okay. Atharv, do you have NCERT book in front of you right now?
Yes, sir.
If you could see one solved example is given. I am actually forgetting the term. Is it integration of
Sir, again you are not audible. Your mic is off. Sir, your mic is off.
one plus 10 cube x was there in the denominator? That was for sure. Numerator, I am getting confused. I am not able to recall that particular question right now. But this question also needs to be solved by partial fractions, breaking into partial fraction. Just give me 1 minute time. I try to find out the question. Meanwhile, two practice questions I am writing for you. Okay, two practice questions I am writing for you. You please copy them and try to find out the solution. Okay, integration of 2 sine 2 theta minus cos theta divided by 6 minus cos square theta minus 4 sine theta. This is the first question for you. Second question for you is x square upon x to the power 4 plus x square plus 1. This is the next question. Oh, sorry, this you will not be able to solve right now. The question seems to be interesting, but right now you are not in the position to get answer to the problem. This question number 2 you are writing as 2x minus 1 divided by x minus 1 into x plus 2 into x minus 3. Third question you are writing is x to the power 4 upon x minus 1 into x square plus 1. Okay. So these three questions I am giving for you to practice right now. Okay. And I am here in the class only. So you can ask your difficulty or doubt. And meanwhile, yes. Meanwhile, I am trying to find out this question also, which I initially could not find out. Okay. I think 1 plus 10x upon 1. No.
Sir, I searched this question even in this partial fraction exercise and even in miscellaneous, but I not to find this question.
So it is solved example given in perhaps. It was solved
Yes, sir.
example.
I saw solved examples only.
Okay, it was not there. I am going to find it out. Okay, I am going to find it out. surprise for me not getting that question. For you, again, this question which I have right now cancelled, let this question number 2 be there for you. Okay. This will be your homework. Let us see whether you are able to find out solution of this question or not. Let me write this for your homework. And homework is concerned, I am writing again few questions. Integration of x square plus 1 upon x minus 1 whole square into x plus 3 and integration of x square dx divided by x square plus 1 into x square plus 4.
The denominator is x plus 3
Yes.
in the right side first question.
Yes, yes, yes. You are talking about this one, I know. And that question which I was about to get, I am not in the position to get that question till yet. Suppose you do one thing. I will confirm that question little late, but you please try to write down this in the form of 1 plus 10 square x upon 1 plus 10 cube x, like that. Okay. So try to find out solution for this question also.
Which you gave na 2 sin to theta wala.
Yes.
So that
Yes.
that not needed partial fraction. Solve the trigonometry linear apart.
Okay, putting sin x is equal to t, you are in the position to go with that, now. Okay. Yes. Go ahead. Go ahead. Yes, this is also, that is 10x plus 10 cube x divided by 1 plus 10 cube x. Right, this also is your homework, okay? So 3 plus 2, 5 questions for you as your homework I have given. Rather 6. I will be unrest till I get that particular question. Unfortunately, that question which I was confirming, I was wanting you to solve, that question I could not get right now. Okay, so I will search it and next week I will be able to tell you that question.
Yes.
And so far as partial fraction is concerned, okay, explanation part is complete. Even practice questions I have given, I am here with you. If you want, you can ask your doubts and difficulties. Homework also I have given. So from my side, the concept of partial fraction is revised for you.
Sir, a hint for the third question. X की power 4 by x minus 1 x square plus 1. I substituted x square as t and x as root t.
No, I tell you one thing. Where are you going wrong? You did not notice. Actually, what happens when we are in flow to solve the question of only one type, then we do not come to know what exactly the question means. Say, what is the degree of numerator? Degree of
To the
numerator.
power 4.
And degree of denominator?
3.
So directly this is the degree of numerator more than degree of denominator. So first of all, you are required to go for division. Directly, you cannot apply the concept of partial fractions. Okay. And anyway, I will give you one small way to solve this question.
No, sir. You gave the hint. Now I will do it.
Okay.
There's still time left, so I'll try this first. And
Okay.
if
Right.
not, then I will ask again.
Right. No problem. I am here only. I am here.
यस सर, हो गए ये तीनों जो आपने दिए थे.
ओके, इवन ये वाले भी.
नहीं, the first three which you gave, sin 2 theta and 2x minus 1 and x to the power 4.
ओके, थर्ड वन. ओके, फर्स्ट थ्री हो गए. उसके बाद ये HW वाले जो लिखे हुए हैं, एक ये क्वेश्चन है. where I am putting my finger here.
Yes
This
sir.
one. ओके, एक ये वाले दो क्वेश्चंस इस तरफ हैं.
Yes sir, I noted them, the
Okay,
homework
okay.
question.
Okay. So now tell me what to do hereafter.
Sir, time is also not left much, 7 minutes.
Okay. So I think we can call it a day for today.
Yes sir.
Okay. So whatever we discussed, you are satisfied with that thing?
Yes sir. Yes sir.
Okay. Have a good day, child. Okay. We can now sign off.
Thank you sir. Good day.
Good day. See you on Saturday. Okay. Bye bye.
Yes sir.
Bye bye.